Let's start with a line, a segment of a line anyway. The line would go on infinitely, but I can't do that, so we'll have a line segment here. And let's pick a point above the line someplace, say here. What I'd like to do is get a line that's parallel to this. It goes right through that point up there. So in order to have something to work with, I'll draw another line that goes through that point and intersects my first line. Say here. And I'd like to have a line that is parallel to my first line that runs right through that point. Now, I wonder if that would work. I don't think so. Or this one. It's kind of hard to say just where it is, but I suspect strongly that if I make this angle up here the same as that angle here, then the lines are going to be parallel and they will not meet in plane geometry, Euclidean geometry anyway. So if I were to get that angle here to match this angle there, that might do it for me. So I'm going to try to copy this angle up there. And that means I have to take my trusty compass and try this one this time. And we'll swing our arc here. And we'll swing the same arc up here. And just like we did before with the triangles, if I can copy the arcs, I'll be able to copy the angles. So let's see what we get here. Copy from here to here. Looks pretty good. And make it the same up here. So if I were to draw my line through this way, right here and right there, the line should be parallel. What do you think? And you know what? I can't prove it. But if angle 1 and angle 2 are congruent, I believe that these lines here would be parallel. They'd never meet in Euclidean geometry. And these angles are both in the upper right-hand corner of their intersection, so they're called corresponding angles. So the corresponding angles are congruent, and if the corresponding angles are congruent, then we propose that the lines are parallel. That's interesting. I wonder if it would be true the other way around. I mean, if the lines are parallel, would the corresponding angles be equal? And that would also be true, I believe, and neither one of them can I prove, but they're both going to be nice little postulates, and one is going to be a converse of the other. But if the corresponding angles are equal, then the lines are parallel. Now, if you will remember, we just had shown not too long ago that the alternate, I said that wrong, that the vertical angles are going to be congruent to each other, and angle 3 is a vertical angle with angle 1, so we know they're equal. So that would mean that angle 3 would be congruent to angle 1, and we know that angle 1 is congruent to angle 2, so that means that these two angles are going to be equal to each other if these two are. So that gives us what's called alternating interior angles, and we could say that if the alternating interior angles are equal, the corresponding angles would also be equal, and then the lines would be parallel. So you could make a little theorem and prove it that if the alternating interior angles are equal, then the corresponding angles must be equal, and then the lines must be parallel, because that's our postulate. And by golly, we've picked up a couple of interesting little things here.